Okay. Hi, everybody. I'm Chris Harrison, and I work for Funeral Zone. We write software to help bereaved, and we're now the largest online funeral resource in the UK. Number one on Alexa. Today, I'm going to be talking about event sourcing, which is a concept that we've started to use in a new software project that we're writing. So, this is an example business domain that we're going to use for the purposes of this demonstration of how event sourcing can help with quite a lot of things. So, at Funeral Zone, we're quite into domain-driven design and modelling our business domains as a pure model in the code from what the actual business concerns are. So this is an example business domain which is based on an online obituary, and this is set by the business, the example business. Required information, name of deceased, date of death, obituary text, and optionally for an obituary you can have an image of the person that the obituary is for and their date of birth. So if you were given this model as a developer, as a programmer, the first thing you normally do is you say, right, what's the data structure? What tables do I need to represent this this model? So you might do something like an obituary table, a user table, and we record who created that obituary by linking up the user ID on the obituary to an ID on the user table, to a row on the user table. You immediately start thinking of this sort of structure when you think about how am I going to represent that online obituary. And this is an example of some data that you might have in there, and you note that the image for the obituary is a string, a path to the image, maybe relative, or whatever. So you design the tables and you roll out the product, and you might have a front end, a website front end, displaying the obituary, and that front end is being powered by that database structure behind the scenes. But then what happens is the business changes their business domain, and they've now decided that instead of one image for every obituary, you can now have multiple images for each obituary, maybe a gallery attached to that obituary. So what you have to start doing is thinking how you're going to change the database structure, and how am I going to fit in multiple images, even though before it was just one column with the image for that obituary. So you think, right, okay, I'm now going to split up my images into another table, an images table. I'm going to make a pivot table to describe that relationship between which image goes with which obituary. And if you've already rolled out your product, you'll have data in the old database structure that is now wrong. So the image is in that column. How are you going to get that image, that path out, and migrate it to a new table? So that's what you do. You have to run through, you have to run a migration, run through all the data, and convert it basically into the new structure while you're in production. So let's go back to the beginning. Revisit that business domain as it was originally stated. But this time, instead of modelling it as a data structure, we model it as a set of events. And these events are pure domain-driven events. So in domain-driven design, we talk about domain events. But we're also going to be thinking about persisting these events as our mechanism for modelling this business domain. So we've got, instead of that database structure, we now have a set of events. We've got obituary was created, and this was the data. And so an image that was created would be a property on that event. And then the text was change and it's just a set of events. Straight away, there's already an advantage to doing this because you now have a richer model. I said at the beginning that the business domain had the requirements that some properties would be optional and some would be required, but that wasn't actually modelled in our database structure. You could change any of those properties if you went into the database and changed the properties. Now, in terms of events, if there's no change, whatever it was change, whatever the non-changeable field was, if there's no event for that, then you can't change it because there's no event for it. And also, the other thing I was going to say was you'd end up coding that requirement about which things you can change and which things you can't. Outside of your main model, you'd have some code somewhere that did a check maybe on the input that was coming in. It might end up in a controller, and if you change the controller, you lose that knowledge about the business domain. The other thing you get is a free audit log straight away because you're persisting a set of events. You know how that data changed over time, so you don't have to do anything to build an audit log because it's already there because it's part of the design process. You don't have to do all of this messy migrations anymore because if a change is made to the business model, instead of saying we're going to change the database structure, all we have to do is just add a new event. So now gallery we just added is a new event in our system. So you're probably wondering, how do we get that set of events into something that's a final front end? And the process in event sourcing, you start with the front end, just like anything else. You go to the application layer, and then you hit an obituary repository, but this is an event-sourced repository rather than just a repository that just gets raw data from the database. What it does internally is you start off with an obituary object and you apply the events. So obituary is created, it hits this event, it decides how to change the object based on the event. And it just goes through the events one by one, and you end up with the final state of the object coming out of the final state of the object comes out of that replaying of those events and returns it back to the front end. There's lots of frameworks for helping you to do this approach. We're using Proof at the moment in our company, which is a PHP framework for doing event sourcing. The really popular one is Eventuate, which is a Java-based thing, and Proof's borrowed a lot of concepts from Eventuate. That's it. That's a lightning talk about event sourcing. We're hiring.
Any questions? Those are questions, hopefully. Yeah.
So when JetBlocks goes onto the website to see the obituary, the computer quite literally says, goes to the database and goes, oh, ding they are. It actually goes through every step of the changes, or does it save a snapshot of all the changes that ended up today?
Yeah. There's actually a concept in Proof called snapshots. So this is the real basics of how event sourcing works that I've described here, but there's a lot of other stuff around it. So snapshots is one of those things where you don't have to always go through and play every single event if you don't want to. If you want to make that performance enhancement, there's a way of just saying, in production, let's just get the last snapshot, and it builds the snapshots out of those event-sourced repositories. Yeah?
What sort of database do you need to do?
It's completely database independent. All that you have to do is be able to persist events, and that can be anything. It could be a text file with a set of JSON events in it. Proof comes with a MySQL based event source repository, and it's also got MongoDB, I think, and a few others. So it's really not dependent on the database at all.
Sounds pretty much like standard object-oriented programming to me. But do you have any kind of transactional model on this? If you've got multiple users and multiple applications accessing this system, do they get tangled?
No, so you're always just appending events to a stream of events. So you're not dealing with the final state at any point. You're always just saying something's happened, so an event's happened, just persist that event to the end. What happens with that later and how that data is rebuilt is a different issue. But you can always replay the events and build up a new state. So,
but if this is implemented on an SQL database that has a transactional model, do you have access to that? So that you've got some sense of whether,
if it was done on an SQL database, it would just be new row to create that new event.
I mean, I think in this case, the transactions, a transaction is an event. If you want something transactional, you just make a single event for it. And then you can't break it into small things. So that problem solved.
In domain-driven design, there's this same concept of an aggregate.
Several events, and you want it to be
a single event, which incorporates all.
Everything that a user does is one thing at a time. So everything that a user does becomes one event, and it's the way that you model domain. Domain-driven design has this concept called an aggregate, which is a set of data which is invariant. So anything outside of that aggregate should be a different event.
So I imagine if you wanted to do it like the classic would be like a simple banking system where you get a couple of bank accounts and you want to move money from one to the other, and you wanted it to be an atomic transaction, you move from one and add it into the other. Be two state changes there that go together. You don't want someone getting a look in the middle.
No, you'd have one event, and you don't have two separate things. You only have the events.
Okay. so the event isn't moving the money. The event is saying the money has moved. So you would persist that as a...
The only thing that you persist is the events. You don't have a database structure with a set of objects.
The events,
you just have the
events
event.
belong to the class then?
No.
It belongs to the domain.
An event, in proof, an event is a class.
I was just going to ask a similar sort of question. Presumably, I mean, I work with something similar where you build up the events to record the history of a drawing object or something along those lines. But I don't work at this kind of level where you might, I'm having trouble seeing how you might sort of build relations for a large database where you're doing queries across multiple sort of
that is
tables
true.
in the traditional sense. Does it just work by, if you wanted to do that sort of thing, would you end up taking sort of snapshots and exporting them into tables which you then query?
It does get tricky when you have massive domains. If the domain's big, it's quite hard to model because you do need to, the best way is to have one event and that's it, and the state changes based on that event. But it is true that sometimes you would have two different aggregates that needed to change at the same time and they needed to be consistent. And there is a concept called a saga, I don't know if you've heard of that before, which what it does is it opens up a new saga as the event, the event happens and it opens up a new saga and it says, this is the state that it is now, but I'm waiting for other things to complete, and once they've completed, I'll listen to those events and feed back into the saga. But it's mainly for doing microservices where you have things in completely different systems and you can't guarantee the consistency. But ideally, you'd want each aggregate route in domain-driven design, which is not thinking in terms of objects like user, gallery, blah, 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 but thinking in terms of one bounded context of data that always goes together and doesn't change. And you try to model the data first to be in that format, rather than trying to twist the event sourcing to match traditional OOP simple objects for each thing, if that makes sense.
Yeah, I think the key is to not think about your data structures first, or your database and persistence layer. To think about the objects that exist within your domain and model those first.
Yeah.
Well, we've had functional interfaces simple last 30 years. Yeah, so one trying to understand what's new about it. It sounds like a snapshot's an interesting thing. Is there any way of rolling back from a snapshot? Because the idea of running every object forward every time you want to access sounds horrendous from a performance point of view. If you get any sort of size of system. Is there, you mentioned snapshot. Can you sort of go roll back, or is there no need to do
So a snapshot is actually a special kind of read model.
Mm-hmm.
So something that goes with event sourcing hand in hand is CQRS, so command, query, responsibility segregation, which is completely splitting up your system into writes and reads. And read models are models that are created from your events. So your right side is just persisting a set of events,
Yeah.
and then you run processes in the background called projectors in proof, which build up read models from those events. And then when you query the read model. You don't query the set of events that you've persisted.
Sounds like tables and views or something.
It's kind of like a view, yeah. But it's more modelled in your code rather than relying on your database to provide that.
You talk about immutable functions or something, methods.
What sort of issues have you run into with it and how did you solve them?
That's a difficult question.
What are the lines you consider what you use for?
Adam, can you think of anything that we
Well, I think the first thing is actually getting your mind into the event mindset, which is the questions that have happened so far, the questions that everybody has, is moving from the mindset of a table for every object, and every table having columns for properties, moving from that mindset into this happened, this happened, this happened, this happened. It's an entire paradigm that takes a little while to get used to thinking in terms of what happened rather than the way things are. It's what happened to make things the way they are, and the state of the way things are now doesn't exist in reality. It's just you build that up, and once you start thinking about what's happened to make it like that, you don't think about how it is. You think about how it has been.
Yeah,
And then you abstract and you
It's the same as any object-oriented model where you've got private data.
yeah, but in terms of that, you only get told how it is right now. You don't get told how it was previously, before the last change happened.
Object-oriented programming doesn't necessitate having a record of all the changes that have been made in your model.
Yeah.
Just to feed back into what you were saying before about transactions, and that also goes into what Adam just said about changing your mindset, is something that seems like it's going to be difficult to achieve. Like the first time I thought about deletion, I thought, how are we going to delete something? Like, what, just go through and delete all the events? Well, no, you don't. You just make a new event saying, this thing got deleted, that's it. But it's just changing your mindset.
Does it suit certain types of data or certain types of applications more than others? Because I can see
I was having conversations.
an application like e-commerce or something. I can see it being applied to something like that where you would want to trace back what had happened previously.
Yeah, I'd say
So
it's
there must-
really
there must be a
different
need
like
to
that
want
where
to
you
know.
want to see. It's not just about wanting to know what happened from a business point of view. This is a programming technique to be able to write better software. Model
Let's
the
run that
software
deletion
better.
process again. You're saying that if an object's been deleted, it goes through all the steps of creating and changing its state and then deleting it before you find out that it's gone.
Yes.
Whereas,
Yeah, but you can cache stuff and you can work backwards.
so you have a snapshot and look back at it gone.
Yeah, that's what I'm saying. Okay, so you don't have to worry about it.
I have a question. Because you've got all these events, are you able to filter those events on a replay so that you can end up with a different object, if that was your aim? So you can say, okay, I want to ignore the changes that this user did because they went in and did really bad stuff. So I want to remove all the stuff that they did and just carry on with all the changes that everyone else did.
Exactly. Yeah.
Yeah.
That would be a perfect use case of something where you could come in after the fact and do all that sort of application, where you wouldn't be able to do that if you just had a set of tables, because you've got no idea who added what to the table. Whereas if you have a set of events of this person did this to this data, you could write, say, run a new projector to run through all the events across the whole system again and take out all of those things. Yeah.
So wait a minute, so you're saying as a side effect of this, you effectively get a version history of the
Yeah.
object, and you can fork at some point.
Yeah, you could go back to any point in time. You could go back to this morning.
Yeah.
You can do that, of course, if that's what you want to do, you just want to be able to go back in time, you could just do snapshots of your hard disk or something. But this gives you a nice, modelled way of doing things.
During the design process of like the first version you had, quite often you get tables wrong, so you end up early on creating lots of different migrations where you're trying different approaches until you actually get on one that's fairly stable. Do you have the same sort of problem in this approach where you get your events wrong to start with, so all of the initial sets of events are all the wrong thing?
We put quite a lot of emphasis, anyway, before we even started doing this, on doing domain modelling before we start actually coding. So hopefully most of the time we've quite reasonably modelled what the events are going to be for the domain. But the good thing about event sourcing would be that it wouldn't necessarily invalidate what you've done previously if you found that actually your model was slightly wrong, because you can always just add events.
What would you do something about something like GDPR? So, 2 years down the line, Joe Blogs comes on and says, "Oh, I don't want you to keep all of my personal data anymore. You have to delete it." Wouldn't that possibly mess with your consistency?
That's quite a good point, actually. I haven't thought about that.
You've got 9 years.
Well, you absolutely could delete their data to the same extent that you would be able to under traditional relational model, and anonymise it. I mean, if you can pull out all the events that say Joe Blogs did this, Joe Blogs uploaded that. You could anonymise it, or you can just inject a single event on the day he asked to say, okay, this anonymous user who no longer exists did this. If it breaks the integrity of data, or if it doesn't break the integrity of data, if there's been nothing lost by getting rid of his data, then you can remove his data completely, remove his events completely from the system. And at worst, it would be just as difficult as it is under a relational model. And at best, it would be a simple delete star or ID equals Joe Blogs.
Yeah, I think you could probably do something you shouldn't normally do in event sourcing, but you could maybe write a projector that runs through all of your events and retroactively changes your events. You could probably do something like that, and maybe redact the actual data but keep the events in place so that you don't lose the consistency, or something like that. I haven't thought about it much.
Before we start talking about more GDPR, so let's finish. Thanks very much, Chris.